Hello, Senior Recovery, and welcome to another episode of me talking to you. So, for this subunit, we are going to talk about fossils. And fossils can tell us many different things. They're traces of the distant past, is what we're going to call them. So, this is an example of a fossil right here. And some things that fossils tell us are how they lived. So, like, we see these spikes here. Maybe this horseshoe crab used these spikes to dig into the sand or something. So they tell us how an organism lived. They tell us when an organism lived. They tell us how it lived, its lifestyle. It gives us kind of a look at what life was like in earlier times, and it can tell us when it went extinct. So we look at the surrounding rock, and we can determine when that animal went extinct, or when that animal died at least. So there are some ways for fossils to form. The conditions are very tricky because they need to be buried quickly so that they have protection from the outside elements, such as like water, wind, heat, scavengers, all sorts of different things. You don't find a lot of fossils because it's just hard to find them because you need all these nice conditions for them to be able to form. A lot of the times, microbiological animals will help to disintegrate those fossils, so they need to be buried quickly and they need to be buried in a protected area. So the other thing that we want to talk about is hard parts. So a lot of the times when you find hot fossils, you find shells or teeth or bones, and those are all the hard calcium-rich deposits of these animals. Over millions and millions of years, just the soft tissue isn't preserved very well, and that has to do with a lot of things, but weathering and microorganisms get in there, that type of stuff. So you need hard parts, and you need them to be buried quickly, and usually under like loose sediment is the best form of burial. So you see a lot of oceanic fossils because they get buried under loose sediment and then get pressurized over time. So that's just interesting there. So we've got a whole bunch of different types of preservation. We've got, this is fossilization right here. Mineral replacement. So what's going on is the remains of an animal like, a dinosaur gets buried underneath of some soil. It's got some holes that get filled with air, and then they eventually get filled with minerals, and what you end up with is this rock-like substance. It is a rock, but it is a perfect mold of that fossil. So that's what pre-mineralized remain is. And then we've got coal. So coal is just organic material. It's dead plant, dead animal. And so what happens is it gets buried and it gets smushed down, and a lot of heat and a lot of pressure turn it into this nice little like oily substance, but it's hard and can be burned. Then we've got molds and casts. So the hard part is buried, it gets compacted and cemented around it, and it leaves a hole as a copy. So the mold and the casts aren't the original remains, it's a copy of the remains. And for example, a cast is like in the Natural History Museum, a lot of the fossils that you see there are not fossils, they are casts. So if you like blow on a fossil, then it could disintegrate. So what they want to do with their fossils is keep them preserved for as long as they can. So they make a cast of that fossil and then they put it out there for everyone to see so that people can't screw it up further. And then we get carbon film. So carbon film is just when an organism dies and it gets cemented and kind of gets into that mold and cast form. Heat and pressure release gases, which is carbon. They release the carbon of that fossil, and it leaves a film. So I'll show you an example of that later. Carbonaceous film is a long word, but essentially it's just like an indentation, basically. And I'll show you a picture. It looks really cool. And then we have original remains. These are the hardest fossils to get. So when you think of original remains, think of amber and like permafrost. So when they find woolly mammoths out in like the Arctic tundra, those are preserved very, very well because they have been compacted underneath all this ice and kept cold, and they have been able to be preserved pretty perfectly for a number of thousands of years. And amber is another example. If you think about Jurassic Park, how they get the dinosaur DNA is they have a mosquito trapped in amber from the Jurassic time that sucked blood from a dinosaur. They extracted the mosquito and from the amber, and they extracted the blood from the mosquito, and then they used DNA sequencing to make these animals, these new age dinosaurs. That's not really feasible yet, but could happen. And then we have trace fossils, which we're just going to think of like dinosaur footprints that get cemented, and then when you see the fossils of dinosaur footprints, those are trace remains. And then trails and burrows, so like for worms, or even sometimes you can see the remains of trails from early mammals or burrows from early mammals underneath the ground. That is going to be like a mold and a cast, but it's in its little separate area because it's kind of also a trace fossil too, so it just has its own designation. So here are some pictures of a mold and a cast right here. So this looks like an ammonite. Actually, I'm not sure what it looks like. An ammonite or a large centipede was. It died. Its hard parts got covered up by sediment. It got pressurized, and what's left is this cast of what it used to be. So this is not the original remains. And then here we have carbonaceous film right here. So this is not original remains as well. This was a cemented fern leaf that eventually, due to heat and pressure, released all of its carbon and left this really, really nice filmy carbon layer here. So it looks pretty perfect. So carbonaceous film is going to leave these really nice remains here like that. And then down here we have pre-mineralization. So what happened was this, whatever this was, if it was like a sand dollar or something, it died, it got buried, and then as it disintegrated, it was filled in with minerals, and the minerals hardened and kind of left this really cool outline of what used to be there. So that's pre-mineralization. Okay, so index fossils. I love index fossils. So the important thing to know about index fossils is that they're organisms that at one point in time were geographically widespread, and they can be used to determine the age of the rock. So a lot of them had distinguishing factors as well. So we have index fossils that are alive today that have changed very slowly over a long period of time. So we can look at their life cycle and determine where in a certain area of rock they are, how old that rock is. So an example is a trilobite. So a trilobite is like a little insect. It's got a three-lobed body that has not changed, the three-lobed body. So what has changed is the size of its eyes, the number of spikes it has, that type of thing. So we can go back and we can look at this trilobite in a rock layer and see, oh, hey, it's got 20 spikes. So the 20 spike trilobite was only around 200 million years ago. So we can safely say that that rock layer is 200 million years old. So that's how we use index fossils, is we know that they were all around the Earth at a certain period of time. They have these distinguishing factors that we can look for, and we can measure the relative age of a rock through that. So we'll do right here, we'll look at this. Parasphintes tiziani. So Parasphintes tiziani was only around in the Jurassic period, but we see it in this rock layer, in this rock layer, and in this rock layer. So we can safely assume that these three rock layers were around or are of the same age. So these rock layers were created during the Jurassic period, or relatively speaking. So we know that. We'll go to another example here. We will look at this little bug guy. I can't see him on here, but we have him in this layer, this layer, and this layer. So we can safely assume that this rock layer right here is all of the same age. So some things you can get into are like disturbances in uniformities, which means that the rock layer has been disturbed. So right here, the rock layer was disturbed. So we can't just go along a straight line and see how old each rock layer is. So that's why we use index fossils. So we go in this straight line here. We see this fossil here, Paraphragmestes tizianti. It was right here, we'll say 200 million years ago, or the Jurassic period. And then we get this area where we don't have rock, and we go back to this rock layer over here in location 2, and we see that same index fossil, so we can say this rock layer was around during the Jurassic time. And then we can go, oh, there's no rock layer here, so we don't know. And then we can go to location 4, and we see this index fossil again, and that's going to tell us that this rock layer right here was made during the Jurassic time, or at least was around during the Jurassic time. So that's what index fossils are used for, is kind of relative dating of rocks, which is very important in understanding the age of the Earth. So, fossils and ancient environments. Fossils can prove changes in the environment, like index fossils, like what I was just talking about. So we can find a tropical organism in a desert. And a really, really good example of that, we have it here, is the Western Interior Seaway. So a long time ago, this whole area, this was about 200 million years ago, this whole area was inundated with water and was actually just a big sea. So we have Colorado right in here. It was actually completely inundated with water. So when you go to the Garden of the Gods, you can actually see a lot of ammonite fossils and a lot of fossilization, and that's because this was inundated with water, and they were able to be buried quickly and had certain conditions to where fossilization occurred. So we actually find these oceanic marine animals in Colorado, which is not an ocean anymore. So that's interesting to know, and it's just another way that we age the Earth. So that should be it for this lesson. Let's see if we've got another slide here. I don't believe we do. So that is it. If you guys have any questions, comments, or concerns, go ahead and let me know. This unit should be just a quick overview of what you need to know in the quiz, and we will get on to, I believe, absolute dating next. So have a good one, and I will see you on the next video.